Okay, today we're going to use our unit circles to graph the sine curve in its original form and the cosine curve in its original form. We're going to graph it by hand on this graphing paper. In this section, calculators aren't good at all, really. They don't do anything for us. I wrote down y equals sine of theta, then y equals cosine of theta, and someone made the point, I thought cosine was x. That was wonderful. Cosine is the x-ordered pair when you go around the unit circle. So when you go around the unit circle, cosine of theta is x, sine of theta is y. But now we're switching gears and we're going to actually graph the functions. So when we graph, we graph under y equals. Okay? Just to show you in general, I have cosine here in blue, sine here will be red. That's the shape of the sine and cosine curve. Okay? It's real important to recognize, again, sine is in red, everyone. The sine curve cuts through the origin with what I call an uphill or positive slope. See it right there? The cosine curve, the high point is on the y-axis. There's definitely a difference. You want to recognize that difference. Okay? So we're going to graph those two curves. I don't know if we'll get it finished today, but we're going to start on it today. But we're not going to draw the curves. We're just going to use our marker and put a dot everywhere there's supposed to be a dot. That's why you have the markers. Okay? These two notes are very important. So you can, again, put them on the bottom of that or in the gap there between the two graphs. You're going to graph sine of theta. This is the basic shape. You're going to also graph cosine of theta. This is the basic shape. Please do your best to draw those two little curves. Anywhere on your paper, there's fine. Keep them on the back. You just want to have that somewhere. You need your unit circles to do this, so please grab a good unit circle that you already graphed. As we move on, these two set of notes here are very, very important, probably the most important. What I want you to realize, again, when you're looking to graph sine of theta, it starts at the origin, or it cuts through the origin with a positive slope, an uphill movement. The cosine, the top of the curve is on the y-axis. Big difference there. All right. If you look at your y-axis, I have 1/2 and 1 written down, but I didn't have the 0.25 and 0.75. I think it's important to make sure you know that's what those slash marks represent. You don't have to write it again. I just wanted you to have it at least one time. If you write it again, it'll kind of get in the way. So if I'm at the origin, I can go up by 0.25, 0.25, 0.25, 0.25. Those will be my values. If you go in the down direction, they're negative. On the y-axis, we're going to plot these numbers that come from the exact value trig of our unit circle. So when we put a dot on the y-axis, it'll be one of these numbers, positive or negative. Is that all right? Don't do this now. I'm going to back it up and erase it. If I were to plot 0, I think everybody would be okay with 0 being there on the y-axis, correct? 0.5, no doubt. 1, no doubt. Now those can go in a positive or negative direction. Good? Every time you plot the 0.707 or the 0.866 dot, you're going to have to estimate. You're going to have to just get close. hopefully you realize the 0.707 will be between 0.5 and 0.75. So maybe about here when I go to plot it. The 0.866, maybe it'll be about here. Then I also got to be able to do that in a negative direction. So when you go to graph this by hand, you're going to plot points. Those will be the y values. There won't be any others. Your y values will either be 0, 0.5, 0.707, 0.866, or 1. But then also you got to be able to go to the negative direction. Is that good? Okay. Now, everybody please put your pencil, tip of your pencil right here on this graph. And as I go around the unit circle, as I move here, you move right to the very next notch. Is everybody okay with that? And you'll see something. So ready? We're all here. You're going to move to your right. Boom. Keep going. So as you move to your right, was every notch accounted for? Yes or no? Right, there were no extras, right? So every one of those notches out to the right on your graph on the x-axis, on this graph right here, every one of those notches is a place on the unit circle as I go counterclockwise. As I go counterclockwise, you're moving to your right. Every notch is accounted for. So that is the x-axis. The unit circle is the x-axis. If I go back to the unit circle, please do this. Go back to the, put your dot on the origin again, your pencil on the origin. Now you move to your left. Every time I move, you move. Ready? Go. Just move to your left. You'll notice every slash mark is accounted for. Those slash marks are these numbers here. I'm going clockwise, so you're going left because that represents negative rotation. Everyone was accounted for, correct? Yes? All right. So that's your x-axis. That's where your x-axis comes from. When I went counterclockwise, that's one full cycle of the sine or cosine curve. Then I go back clockwise, that's another full cycle, one trip around the unit circle. One is a positive direction, one's a negative direction. That's what these graphs are. If I start here and rotate counterclockwise, that's one trip around the unit circle for sine, also cosine. If I go back to the origin and go clockwise, it's one full trip around the unit circle for sine, also cosine. Everybody good? Okay, so now grab your markers. Let's go to that second graph that we haven't written on yet. Let's focus on, let's graph y equals, my goodness. Let's go y equals cosine of theta. Let's do it on the second graph that you haven't written on. Yes? I can hear you. Oh, is there some back there? So you all know what these numbers represent now. Your paper just has 1/2 and 1 on the new graph. negative 1/2, and negative 1 on the new graph that we're going to now, the second graph. But you know it goes by 0.25. Everybody sure of that? Okay. So have your unit circle beside this paper. If I'm here, that means I'm here on the unit circle. When I'm here, cosine equals 1. Everybody agree? Well, let's make a dot. When I'm here, cosine is 1. Make a nice big dot right there. So when you're at 0 radians or 0 degrees, the answer for cosine at that spot is 1. This next notch would be 30 degrees on the unit circle. So your next notch will have a dot on the y-axis at 0.866. So this dot, you'll have it, or at this notch, you're going to estimate what you think 0.866 is. Please be directly above that mark. Make sense? I'll get this right. Your next move will be 0.707. Your next move will be 0.5, and then your next move will be 0. Everybody see where I'm getting the numbers from? So as I move on my x-axis, I'm moving counterclockwise. That's my x-axis. When I'm there, cosine has an answer. 1, 0.866, 0.707, 0.5, and 0. So the next 0.707, do your best to estimate that. The next 0.5, the next is 0. You're starting to graph your cosine curve by hand. Yeah, with the marker. So far, so good. All right. Well, this next x value, once again, comes from the unit circle. So as I continue to the right, this is my next x value. Cosine will be negative 0.5. Cosine will be negative 0.707. Cosine will be negative 0.866. And cosine will be negative 1. Okay? Well, your move on the unit circle, which is here now, cosine is negative 0.5. Next, cosine is negative 0.707. Again, you're going to get close as you can. The next, 0.866. The next, negative 1. You're getting as close as you can with these dots. We're not going to be perfect with the graph paper that we have. Well, if we go back to where we're at on the circle, we're here now. So as I continue, my next mark, negative 0.866, negative 0.707, negative 0.5, and 0. Those would be my next marks. So you move, again, try to stay lined up with your mark. Negative 0.866, negative 0.707, negative 0.5, and 0. Again, this isn't perfect, but we're going to be close. Then you're on your home stretch. The next mark, cosine, 0.5, 0.707, 0.866, back to 1. So it'll go up now. Okay, so back to 0.5, 0.707, 0.866, back to 1. Now again, these intervals, I just kind of drew this freehand. They're not perfect. But in general, don't draw this curve. But in general, this is your cosine curve. Okay? I don't want to see the curve. I just want to see dots. Back to the circle now. We already have this dot. Now I need to go this direction. So if I'm at the origin, my next mark is here. And on your unit circle, you're going to go this direction now. So you're going to do the same thing going this direction. So that very next mark, 0.866, 0.707, 0.5, and 0. One in the other direction. So this mark, 0.866, 0.707, 0.5, and 0. Back to your circle. Next mark, negative 0.5, negative 0.707, negative 0.866, negative 1. And you just continue around your unit circle. And you'll notice the pattern. Try to stay lined up with your marks. It's kind of difficult with the papers that we have. That will be the other half of your cosine curve. Again, don't draw the line. I got off too far. Okay. 0.5, 0.76. Now back to 0.866. There, that's a little tighter. And then it'll continue again one more time. That'll finish off your curve. So your paper will look something like that. Again, we're only going to have dots. So you have to understand as you move on the x-axis, you're going around the unit circle, those are your x values. When you're at one of those spots on the unit circle, cosine has an answer. We're not doing exact values now, we're using the decimals 0, 0.5, 0.707, 0.866, and 1. Do your best to line up vertically with the slash mark and it'll look better. Again, the graphs we have, it's not going to be perfect, but I think you'll get the idea. Everybody good with that? I'm going to give you another paper. You're going to try sine. Okay? The difference will be when you start sine of theta, when you're at the origin, you're going to stay at the origin. The first dot's 0. Then it goes to 0.5, then it goes to 0.707, 0.866, and 1. That's how sine starts. Okay, I'll give you another paper in a minute. But just to show you, sine will start here. Then when I move out to that first slash mark, sine's 0.5, then 0.7, then 0.8, then 1. So sine will come off like this to start. The idea is the same though. Okay? So the next graph paper I give you have two graphs. So try to get a really good sine curve and a really good cosine curve before we're finished. You got to have a good unit circle for this to work.